I was hoping to go a little bit more specific into each of the four domains, right? And you know, if you can speak it to your best of your ability, that's fine. So if we start with the domain of gas compression, right? Could you give us your perspective and maybe any knowledge you may have on sort of what is state of the art for gas compression technologies, and is there anything new or emerging that might be a step change in how gas compression happens or how it's conducted? Yeah, and is Shell doing anything interesting or novel in this arena?
So this is kind of past where I was in the project execution. Because so my space was from the top hole, so to call it, subsea, to where the gas hydrocarbons would land on a platform, and then when it goes so compression. Yeah, I'm assuming you're talking about you in the process of the liquefying the gas. Is that where you are now, or?
So more compression in terms of like you know, moving gas from the platform or from the wellhead offshore to an onshore plant, and then compressing it for any processing activity that may need to happen.
Yeah. So I could find some information from you, from some of my colleagues, and find out what's being done there. But I will, with the project knowledge that I had, so my scope ended at the hydrocarbons getting onto a platform. So from the wellhead to the boarding valve, or was where boarding valve, which is getting onto the platform, was my domain, and that's what I'm familiar with. So when I talk about pumping gas, we're talking about boosting the pressure from the wellhead coming on up to the platform. So I would not want to speak too much on the gas compression process that's occurring after that. Yeah. Yeah,
that's no problem. Maybe we could stay in this your realm, right, of the process. This might be completely outside of it, but an interesting idea or technology that we've come across are these downhole. You come across any of these? Is there anything new or novel that some of these operators are doing?
So now everything that you talked about, we use subsea as well.
Yeah.
So corrosion resistant steel alloys is what we use subsea to cut the pipelines as the hydrocarbons are flowing back to us. Mag, we use that. I mean, I don't know that anything changes from the subsea infrastructure to an onshore facility. No, I think they're dealing with the same issues and remediating them the same way.
Yeah, I think we've
got the only thing is that the only difference is that sometimes for subsea development, what we are questioning is, do we need, because we're gold plating our projects, that's why our projects are so costly, because we don't know what's in the reservoir until it starts hitting us. That's when we know for certain what we're dealing with. So the flow assurance guys' challenge is the sample that I'm getting really reflecting what's in the reservoir. And then how so they're challenged, we challenge them a lot as to, do I really need all this stuff that you're putting in? Because whatever remediation solution that they're offering, we have to put it in the whole structure, coming all the way back from the tree to any connector to any part of that. Otherwise, there's a weak spotlight where now we're left exposed if we don't put the corrosion resistant alloy in there. So those are the challenges. But so those challenges don't exist for the onshore because now the onshore flow assurance person already knows what they're dealing with. Yeah.
Interesting. I want to stem off that question, right? So a question that we get asked is sort of how the technology stack changes for different gas plays that are available in the world, right? So we keep hearing all the time Qatar has very clean gas, wet gas, while other areas, whether it's Mozambique, Angola, Brazil, they have very different gas types that will affect the technologies applied, right? To your best.
I've done everything you can imagine, and I followed it up all the way. And then I moved to the commercial side. So technically, Shell has been very obsessive about being innovative because Shell thought, because of its ancestry of Dutch who are very, very engineers, so most of our Dutch are engineers and most of our British are negotiators. If we are still British and Dutch, I think I was the first, one of the first to come and change the game. I was Lebanese, Armenian, and then French educated. Nobody's perfect, but they took me. And so the focus on technology is obsessive because we think we do not have the American government backing us. We don't have big, Aramco type of government. If we're going to compete in this world, it's going to be because of our technology. And now, of course, we're moving to some trading and so on, and our scenario planning. We strategize to death.
Great.
So technology, we spent I think 1.2 billion or 1.1 billion in R&D. It's the highest of any other IoT.
Yeah.
And a lot of it goes to gas pipes.
Oh, okay. Do you? Before I ask you another question, can you give us a sense of how much goes to gas-related technologies versus other domains?
Yeah. I don't know lately, but what it is.
Okay.
But since we are on a destination fuel, I know that there was a lot of push. The last time I went to the research center in Amsterdam and Rijswijk were 3 years ago, and so even on LNG ships, we push the envelope to get to the next ships and how to improve their efficiency and so on.
Yeah.
So there is a kind of an obsessive move in that direction.
Yeah. Do you even have like a range or percentage? Because you'll see as we ask you some questions is that we're trying to understand how some of these companies conduct R&D internally for this versus externally, and what that sort of breakdown may look like. But before we get there, do you have I just get a broad view? No? Okay. That's fine.
No, for example, on gas processing, where I was definitely involved extensively, we always try to have our own proprietary sulfinol units. Yeah. The market has fantastic gas, extraction,